Okay. Hello, everybody. We're back. Now we're going to continue our discussion about the movements of the arm. You'll notice when we move this SketchUp drawing around that it has those little lines that it puts in the drawing, and this is because this drawing is so complicated that when you move it, the computer has to take a minute to redraw the picture. Internal and external rotation of the arm is demonstrated in this sequence of robots. Internal rotation, external rotation. Finally, one more time, because I need to emphasize this point. Where did these words come from? I do not know where these words came from. It's just the words that the scientists decided to use. And that's, if you use these words, then everyone will know what you were talking about. Traditionally, internal and external rotation of the arm are demonstrated, though the motions of internal and external rotation of the arm are demonstrated with the arm in this position. So we have to go back over here to our original robot, who is in this position, and we have to show how we got from there to what we want to show. And the first thing we did was remove a bunch of parts so that everything is easier to see. And you will notice, if you look, this little blue circle is about right here. And that just shows that this abduction-adduction axis of rotation is parallel to the floor. That's what we're showing here. So in order to get this arm to be up in front of the robot, we have to do a couple of things. One of the things we have to do is do some flexion extension. So we've rotated this blue line. You see this blue? We've rotated this whole structure, which was the structure that allows flexion and extension. So we've rotated that, and you will see that we have rotated that over from here to there. That is flexion and extension. You will see that this takes the abduction-adduction axis and changes it so that instead of the abduction-adduction axis being parallel to the ground, it's now perpendicular to the ground. And once we have it perpendicular to the ground, then we can do some abduction and adduction by swinging the arm around the abduction-adduction axes, which are this one, and that one. So what we did by doing that is we swung the arm over so it's pointing out towards the front of the robot, and the upper arm is pretty much parallel to the ground. And the last thing that we did in order to get this arm to demonstrate internal and external rotation is we actually did some rotation of the arm, and I will show you that, again, this particular robot has been optimized to demonstrate internal and external rotation of the arm.